In this video, we're going to talk about the common operators that are being used in physics practical, and the second part will be on the data representation in tables. Let's start with the operators highlighted in red: protractor, ruler, and your spring balance. In general, you can take the measurement to the smallest division. Okay, so that means to say if the line or the thing is in between, you have to decide whether to round up or round down to the nearest division. For example, for the protractor, the smallest division is 1 degree, and the precision or resolution or the values that you can be recorded will be to the nearest degree. So example is like that. For ruler, maybe a half meter rule or meter ruler or measuring tape, or even the ruler in your pencil case. The smallest division is 0.1 cm or 1 mm. So likewise, you are supposed the precision is to the smallest division 0.1 cm. So you must have a point something cm there. And for spring balance, of course, depends on what kind of spring balance. Likewise, is the smallest division. Next, those highlighted in blue, there's something common in all of them. Basically, you can just read off from the display. So whatever that's displayed there, you record down by default, unless otherwise stated by the instructions. So next one is those that in green, you can actually basically read up to half of the smallest division. Alright, that means to say if this is the smallest division and the needle or the reading shows here, you can actually read up to half of it. Alright, especially for ammeter, voltmeter, okay, it can comes in different range. For example, ammeter can be from 0 to 1 ampere range, or another one is 0 to 3 ampere range. So depends. So all these can be read up to half of the smallest division. Now the last one, the one in yellow, stopwatch, okay, a bit special. Likewise, just like the blue ones, you can just read off from the display, and is to 2 decimal place 0.01 seconds. But because of human reaction time or the nature of the experiment, where you are going to observe whether an event has indeed occurred, example when the water starts to boil, for example. So due to all these kind of errors, so it might be more practical to record to 1 decimal place or even 1 seconds, nearest seconds, depends on the instructions given. So if you want to know more about how to operate and read each operators, you can look at the individual videos that I've sent to you. Now, as mentioned just now, those highlighted in green, okay, so whatever values that you read off, those are called readings. And why is it different from those that they are in red? Because those are called measurements. Now, what's the difference actually? So those in green, like for example your thermometer, measuring cylinder, ammeter or voltmeter, the values are found from a single judgment where using the instructions. Now, what do you mean by that? For example, if you use a thermometer, measuring cylinder or ammeter, voltmeter, you don't need to care about the zero, because the zero is kind of determined or set already during the time of manufacturing. So when the needle comes to here, that is the only one judgment. That's why it's called a single judgment that you need to take note of. So you can read up to half the smallest division. Alright. But for those that are in red, like your protractor or your ruler that I mentioned, or your spring balance, the difference is you have to values taken as a difference between judgment of 2 values. So if you want to measure the length of the crayon, for example here, you can see that you have to align one end of the crayon to the ruler. That itself is one judgment. And then at the end here, there's another judgment. So you can see that because of this range of uncertainty, 2 judgments here, you can read up to the smallest division. So this way, it might be easier for you to remember, okay, instead of just memorizing. When can I read up to the smallest division? When can I read up to half a smallest division? So another example is your protractor. You can see that for protractor, you want to measure the angle, you first of all have to align this. So that is one judgment itself, and then another judgment. and the measurements will be the difference between the two judgment of the two values here. And for spring balance, do you know that, I mean, you can actually, this metal plate here, the readings, you can actually adjust it up or down to align the pointer to the 0. So that itself is like a 1 judgment. So in short, your ruler, protractor, or even your spring balance, where you have to determine or set the 0 yourself, then the precision will be the smallest division. So that will be easier to remember. As for other instruments like your ammeter, voltmeter, your measuring cylinder, your thermometer, where there's no need for you to worry about the 0, where the 0 starts, no need to align them. So there's only 1 judgment, so you can read up to half the smallest division. Hopefully that will help you to remember. Next, let's talk about the data representation in tables. Now, usually the leftmost column will be the independent variable. That means you set it yourself or you decide on your own. So usually will be minimum about 6 values here, all right, or 5 minimum. So then followed by the raw data from the instrument that you use, and then usually there will be calculated values. So usually you must do the raw data first. After that, you put the operators, the setup aside, and then you continue to do the calculated values. A few things to take note is the, like I said, the raw data here, you have to follow the precision of the instrument unless otherwise stated. So it must be consistent. For example, can you see the precision of the ruler used is 0.1 cm. So if it's 4 cm, you still have to write 4.0. So be consistent. And for independent variables, either ascending or descending order. Then the rest, ammeter and the voltmeter here is 2 decimal place. The precision is half of the smallest division, so you record down accordingly. And these are called dependent variables because it depends on the L that you set, which is the independent. Another thing to take note is the header here. Make sure the header, for example, length is the L here, so it's physical quantity L followed by a backslash and followed by the units. So the header must be written properly, physical quantity slash followed by the units. And very important, there should not be any units inside the body of the table. So if you're careless, you put a cm here, 1 mark will be deducted. Next, let's talk about calculated data here. For example, R, as you know, okay, R is actually V over I. You're taking the V value divided by the I value. Now, for general, it will be this one. If multiplication or division are involved, the calculated value should follow the least number of significant figure. So if you were to look at the V and I, all these are 2 sig fig. Alright, this is 3 sig fig, but of course you just follow the least. So the least is 2 sig fig. When you take the V divided by the I, 0.50 divided by 0.10, the answer you should leave in 2 sig fig and be consistent. The last column here is the rho, which is your resistivity, and it's given that is resistance times the length. So basically it's the multiplication of R and the L. So you follow the least sig fig because it's multiplication. R is 2 sig fig and your L is 2 sig fig, that's the least. So when it comes together, the answer should still follow the 2 sig fig, alright, for all. In this example, it's a typical pendulum experiment where the independent is the L, the length of the pendulum. And take note of this T1 and T2 with a subscript here, it means to repeat the experiment for the same length and same oscillation. Then T average, and this T here happens to be the period, that means the time taken for one oscillation. And here, the 2 here is the power square. Okay, so it's a superscript, and that means to square the value of T. For the calculated value for this case here, I want you to focus on whether it's addition, subtraction, or averaging. For this case, this is averaging. Operations are involved. The calculated value should follow the least number of decimal place. Let's talk about the raw data first. So when you record the time using a stopwatch, remember I said stopwatch, the precision is 0.012 decimal place, but because of human reaction time, so it will be more appropriate to actually record to 1 decimal place. Usually the question will tell you and you just follow. Next, averaging. So just take note, when you do take average of the two T1 and T2, you follow the least sig fig. So both are 3 sig fig. So naturally the average here will be in 3 sig fig. Now the next one, number 3 here, when there's a division by a constant, except for averaging. So division by a constant, just like this case here, you take the average divided by 20 oscillation. The 20 is a constant. So the calculated value should have the same number of sig fig as the raw data. The raw data is over here, and when you take divided by 20, so it will follow the same number of sig fig. So all these are 3 sig fig, so therefore your period will be in 3 sig fig. And for the last column, t square, you can actually treat it as multiplication. So the t times t. So as mentioned here, multiplication or division are involved, the calculated value should follow the least sig fig. So since all these are in 3 sig fig, so t square will be 3 sig fig also. Very important, must be consistent and no units inside. In this last example here, just take note, of course in general the ruler is precision is 0.1 cm, but sometimes they want you to measure in terms of meters. So 1 to 0.001 meters. That's why it's 3 decimal place. So you just follow, make sure you are mindful of the units, and this is a voltmeter reading to 2 decimal place. As for the last column is given in such a way and in standard form. So in terms of times 10 to the power 6, so you need to be mindful of that. And this one is a division, taking the L divided by the A, and A is given to you. Now actually I'm not sure why is in this value, but in general I just want you to remember, for division you follow the least sig fig. So this is 3 sig fig, and this is can be considered 3 sig fig. Alright, so the answer you get is 2500000. So in 3 sig fig and in standard form, alright, you jump to the left 6 times, so 2.50. Alright, so not to worry about the why is it 2.49, but if it's you just take the L divided by A and you get 2.5, make sure you have to write one more 0 here to make it 3 sig fig. So if you work it out, so all this must be in 3 sig fig, even for this not decimal place but 3 sig fig, 11.3. So once again, no need to worry about this, just take note how many sig fig you live in or decimal place, following the rules over here in general. So I hope with this video you have a better idea how to record the data and also to present the data in the table better.